We're taught to think of gravity as background, not as a character. It's presented as a constant, a law, a quiet agreement between you and the planet that simply never changes. You can negotiate with almost everything else in life, but not with down. So what happens if that agreement fails for just 5 seconds? Not in a spaceship, not in a lab, but everywhere at once. No gravity, no weight, no down to insist on where your body belongs. The unsettling part isn't the cartoon image of people floating like balloons. It's the realization that if 5 seconds of missing gravity are even imaginable, then the thing holding everything in place might be less sacred than we like to believe. If your goal is to feel safe about how the world works, you're going to hate this. Here, we don't repeat the reassuring script. We take the part nobody questions and ask what it would mean if it stopped behaving. This idea usually shows up as a joke. What if gravity turned off for 5 seconds, and someone replies, "We'd all float and then land, haha." Quick, visual, easy to animate. The conversation rarely goes further. The assumption is that it would be a quirky, chaotic moment, maybe some broken bones, but fundamentally a slapstick scene. Anyone trying to dig deeper into what this would actually do to our systems, our infrastructure, our politics, is treated as overthinking a meme. Meanwhile, in physics circles, the question is dismissed on different grounds. Gravity doesn't just turn off, they say. It's not a light switch. You can't casually set the gravitational constant to 0 for a few seconds and then restore it without breaking almost everything about how matter behaves. And they're right. Within our current understanding, there is no button like that. But the point of this scenario isn't to make a prediction. It's to run a stress test. To use an impossible event as a way to see where the weak points in our reality would be, if something or someone could do the impossible. So let's set the rules of this world in a way that keeps the thought experiment sharp without dissolving into pure fantasy. Imagine that, for exactly 5 seconds, the gravitational pull at the surface of the Earth disappears. Not the gravity binding atoms together, not the gravity holding the planet in orbit around the sun. Just the local down you feel standing on the ground. Your weight, the attraction keeping you on the floor, the force that defines falling. For 5 seconds, that pull goes to 0 everywhere at once. You are no longer being accelerated toward the center of the Earth. After 5 seconds, the field snaps back to normal, as if nothing happened. The first instinct is to picture gentle floating, like pressing pause on a movie. But gravity is the thing that constantly counters your inertia. The moment it's gone, everything with even a hint of upward or sideways force is suddenly free to keep going. The world doesn't get calm. It gets wild. Most people, at the exact moment gravity vanishes, are in contact with something. The ground, a chair, a car seat. Those surfaces are pushing up on you with a force equal to your weight. When that weight drops to 0, that upward force is briefly unbalanced. In practical terms, the floor kicks you. The chair pushes you away. The car seat launches you toward the roof. Not with the violence of an explosion, but enough that anyone standing loose might find themselves a meter or two off the ground, drifting, limb flailing, with no way to pull themselves back until gravity returns. Vehicles become their own category of chaos. A car driving over a bump at the exact moment gravity disappears sends its passengers into the cabin ceiling and its own chassis into a subtle, uncontrolled drift. Tires no longer grip. Steering wheels turn freely without traction. The car's momentum continues in a straight line, unaffected by the road surface. On highways, that can mean sideways slides into other vehicles once gravity returns and rubber suddenly bites the asphalt again. In cities, it means buses and bikes and scooters all experiencing that same untethered instant. Aircraft have an even stranger moment. Planes in flight already spend their time balancing gravity with lift. When gravity drops to zero, what happens to lift? A wing moving through air generates lift because of the pressure differences needed to support the aircraft's weight. Take away weight, and the plane is no longer falling. It's just moving through the sky. For 5 seconds, pilots and passengers experience something closer to true free fall. Not because the plane plunges, but because their own bodies are no longer pressed into seats by the familiar downward pull. Loose objects drift. Coffee, pens, bags. The things you were holding 1 second earlier become tiny projectiles as the aircraft's motion continues, but the reference frame you trust, down, disappears. And then the oceans stand up. Water is constantly held in shape by gravity. Waves crash because gravity drags water back down. Tides exist because gravity from the moon and Earth pulls on enormous masses of fluid. Remove Earth's surface gravity for 5 seconds, and the upper layers of the oceans don't just sit quietly. They heave. The inertia of trillions of tons of water suddenly freed from a constant pull doesn't have time to leave the planet. But it does have time to surge upward, sideways, outward. The surface of the sea puffs up, throws spray into the air, forms chaotic, shifting bulges. Ships riding those surfaces lurch in bizarre directions, hulls no longer cutting through a stable down, but caught in a brief, seething zero-G soup. Coastal regions wouldn't watch neat walls of water rise and then fall, like a special effect. They'd see harbors thrash, moored boats lift and slam, port structures take hits from vessels that lost all weight and then regained it halfway across. 5 seconds is short, but enough for a container ship drifting a few meters sideways to come back down misaligned with the dock, grinding into concrete or into another ship. Inside buildings, the scene is different, but just as unforgiving. Ceilings, furniture, stacked objects, everything that relies on weight to stay settled, loses its anchor. Shelves dump their contents out into the air. Ceiling tiles, light fixtures, hanging decorations jerk on their supports. People sitting at desks find themselves rising out of their chairs, laptops spinning, chairs tumbling with no friction to hold them in place. Glass windows flex in their frames as buildings, designed to handle vertical loads, suddenly experience a tiny but real jerk in every direction at once. And then, just as the brain begins to register that something is horribly wrong, the 5 seconds end. Gravity doesn't politely fade in. In our scenario, it snaps back to full strength instantly. All those drifting bodies, loose objects, vehicles, water bulges, suspended structures, everything acquires weight again in the exact position it reached in those 5 seconds. You are halfway to the ceiling when the floor starts pulling you back at the familiar 9.8 meters per second squared. You hit whatever surface is now below you, not necessarily the ground you started on. Someone who floated sideways in a subway car meets a pole with the side of their head. Someone who drifted above a staircase comes back down onto the edge of a step, not the flat landing. The oceans collapse out of their weird swollen shapes back into basins, but with momentum. That means slamming water. Waves crash where they weren't a moment before. Some coastal defenses experience being hit from angles they were never engineered for. In rivers, water that had just started to lift splashes back, potentially overtopping embankments, flooding low areas that hadn't seen a drop of rain. But again, the temptation is to stop here and say, chaos, injuries, some deaths, lots of cleanup. An extraordinary day, but a one-off. The deeper problem starts when the question shifts. Not what happened, but what could do that? Because this isn't like a storm. Weather has patterns. This event would be global, simultaneous, and timed with absurd precision. Exactly 5 seconds. Not 3.5. Not 6.2. 5. Everywhere. That signature alone would kill any explanation based on random natural fluctuation. Whatever theory was offered publicly, the people who deal with threats would know they had just witnessed something that behaved like a command. If gravity can be turned off, even briefly, the most rational assumption for anyone in charge of national security is that it can be turned off again. And possibly not just globally. The same hypothetical leverage that zeroed out gravity over the entire planet might be tunable. Maybe 5 seconds everywhere is just the most obvious version. Maybe 5 seconds over one city, one battlefield, one orbit is also on the menu. That's where the thought experiment stops being weird physics and turns into something much darker, a potential tool of control. Picture a militarized version of this phenomenon, even reduced and imperfect. Switch off gravity locally over a missile silo, right as its warheads are being swapped or serviced, and let them fall sideways instead of vertically when gravity comes back. Disable gravity under an armored column for 5 seconds. Tanks lose traction, crews hit the interior, optics crack, formations scatter. Use it under a naval fleet in calm seas. Decks become short-lived zero-G playgrounds, then instruments, weapons, and personnel all slam back down out of alignment. No bomb crater, no radiation, no smoke trail to track. Just a sudden failure of down. It doesn't have to be perfect to be terrifying. It doesn't even have to produce mass casualties to be effective as a message. A single demonstration over a military base done in a way that leaves no ambiguity in the data. Accelerometers spiking, seismic sensors reading a momentary loss of weight across an entire region would be enough to show that whoever controls this doesn't need to blow anything up. They can simply unhook you from the planet for a few seconds and watch what that does to your ability to function. Economically, the 5-second event would slice through assumptions as brutally as it sliced through physical routines. Insurance models, risk assessments, safety designs, all of them are built on the idea that gravity is stable. If that axiom fails once, even for less time than it takes to read this sentence, the risk calculus behind skyscrapers, bridges, transportation networks, and orbital infrastructure changes. For some structures, it becomes necessary to prove that they can survive not just earthquakes and winds, but a future incident where, for a heartbeat, nothing holds anything down. And if you think that won't be monetized, you underestimate how fast markets adapt to fear. New industries would spring up promising gravity anomaly protection, special restraints for workplaces, redesigned interiors for vehicles that claim to reduce injuries in zero-G blips, retrofitting services for buildings to secure shelves, fixtures, machinery. Governments might quietly encourage some of this, not because anyone knows how likely a repeat is, but because visible measures calm people. The event creates a demand. Someone steps in to sell the feeling of safety back to you. Meanwhile, ordinary people would carry something much harder to sell away. The memory. Remember that 5 seconds from inside your own body. You're lifting your coffee. You feel your feet leave the floor. Your stomach lurches in a way elevators never prepared you for. The cup, the table, the walls lose their relationship to you. For a moment, nothing tells you which way to fall. Then gravity returns without warning. You hit something. Someone else hits you. The world snaps back into place, But now you know it can slip. Official narratives would race to contain the meaning. There would be investigations, panels, commissions, press conferences full of phrases like unknown cause, extremely unlikely recurrence, no evidence of hostile action. Scientists would be on every screen, carefully explaining that while the mechanisms are not yet understood, there is no reason to assume an intelligence behind the event. The line between honest caution and strategic reassurance would blur quickly. At the same time, away from cameras, there would be other conversations. Intelligence agencies would be comparing notes about unusual experiments just before the incident. Military analysts would be combing through classified data for patterns that might point to a test. Any nation with an advanced physics program would be scrutinized. Any rumor about exotic technology, gravity manipulation, advanced field generators, black projects, would suddenly look less ridiculous inside secure conference rooms. Because even if everyone involved privately believes the phenomenon is natural, the possibility that it isn't becomes a strategic fact. You can't afford to ignore the idea that someone else might learn to do that on purpose. And once you accept that, you start planning for a world where gravity can be tampered with as easily as communication signals. That world does not look like our current balance of power. Traditional weapons are built around the assumption that down is reliable. Armored vehicles depend on traction. Infantry depends on the ability to stay on the ground. Ports, airports, runways, launch pads all hinge on predictable weight. A force that can selectively compromise, that doesn't need to be larger or richer or even technologically superior in every way. It just needs to be able to push that one button where it matters. The people who lose the most in that scenario are the ones whose security architecture is the most gravity-dependent. In other words, almost everyone. The ones who gain are those with early access to whatever principle might be behind the 5-second failure, whether they understand it fully or not. Possessing it would be less about immediate use and more about the shadow it casts over every negotiation. The unspoken awareness that, if talks go badly, there is a lever. What makes this thought experiment uncomfortable isn't only the spectacle of cars and oceans and people briefly floating. It's the way it forces us to admit how fragile our sense of normal actually is. We like to think we live under laws of nature that are not just consistent, but morally neutral, beyond tampering. Gravity isn't on anyone's side. That's part of the comfort. The moment you picture a universe where gravity behaves in response to something, a device, a decision, an accident in a lab, you also picture a universe where the boundary between natural law and human power is blurrier than we pretend. Maybe that's why versions of this scenario rarely get past the joke stage. Treating it seriously means entertaining the idea that the most basic part of your physical experience could be subject to failure or even control. It leads to ugly questions. If someone, somewhere, was close to discovering how to induce a local gravity drop, would you ever hear about it before it was militarized? If there had been small-scale incidents, strange, localized 5-second anomalies over unimportant regions, would they be reported as they are, or quietly relabeled as sensor glitches and equipment malfunctions? The official stance will always lean toward stability. The laws of physics are not changing, they'll say, and they might be right. But 5 seconds without gravity, even as a purely hypothetical event, shines a light on an uncomfortable truth. Every structure of power on this planet depends on the assumption that the invisible forces holding us down are not negotiable. The moment that assumption cracks, even in imagination, the hierarchy of what truly matters is rearranged. So when you hear the question, "What if gravity turned off for 5 seconds?" you can answer with the simple image: people floating, things falling, a global bruise. Or you can follow the darker line it suggests. If the floor beneath everything could vanish for that long, who would rush to claim the ability to make it vanish again? And if such a switch ever came into existence, do you think it would be designed with a label the public can read? Or hidden in a place where most of us would only learn about it when the next 5 seconds arrive?